Alright, so we're looking now at number 21, and we've got NaCl plus AgNO3. The first thing we want to do is maybe draw a picture and see what these look like so we get an accurate picture of how many there are of each ion. So we've got NaCl, we've got Ag and NO3. Now you've got to remember with NO3 that's a polyatomic ion. That's one NO3 group, not three NOs or anything else like that. So we've only got one of those, and that's going to be important for later. Now we know that what's going to happen is the Na will join with the NO3, the Ag will join with the Cl. To be helpful to have the charges on these as well. We know Cl has a -1 charge because it's in group 7. Sodium will have to have a +1 charge to make that balance. We know NO3 has a negative charge from the polyatomic ion sheet, and that means that the silver needs a 1+ to balance that. So it'll be Na will join with the NO3, and we'll have the Ag joining with the Cl. And it's really important that we just take one of everything over to the other side. We've only got one, so that doesn't make that so difficult, but that's the way we always have to do it, even if there does have to be more than one of these on each side. Alright, so now what we're going to do is we're going to redraw this and show how all this comes together. We've got NaCl plus AgNO3. That's going to give us NaNO3 over here, and we've got AgCl over here. If we look at the solubility chart, we'll see silver chloride is a solid, and I haven't written AQ on any of these, but what we're going to do is anything that doesn't have anything on it, we're going to make it AQ, and we're going to make the solids the S's, so we're just going to assume that these are all aqueous over here. When I try and balance this up, you can see I've got one sodium, one Cl, one Cl. We've got one Ag and one Ag, and one NO3 and one NO3, so that's all balanced up. And again, I won't write the AQs on here, we'll just assume that they're there. The next thing we want to do is do part B, which is show the full Ionic equation. So to do that, I'll draw pictures of everything we've got here. So we've got NaCl, so it's just going to be Na and Cl. The charges will be plus and minus, and we can get the charges from up over here, plus and minus here. And we've got the AgNO3, so it'll be Ag and NO3, that'll be minus, and that'll be plus over here. The NaNO3 would be Na plus, NO3 and minus. And the AgCl does not split into ions because it's a solid. So any times it's a solid, just leave it the way it is and don't try and split it into ions. Well, we want to try and figure out how many of each we have. We've got one Na plus, we've got one Cl minus, so that's how that'll split into ions. We've got one silver plus and one nitrate, that's how that splits into ions. And we've got Na plus and NO3 minus. Always need plus signs in between these because these are how these split into their respective ions. And then we've got AgCl solid, which doesn't split into ions because it's a solid. Alright, so that is the answer to part B. We're now going to do part C. In order to do that, what I'm going to do is I'm going to take this, I'm going to copy it into part C. Alright. Okay, so there we go. Alright, so this is for part C. And what we're going to do here is we're going to get rid of any of the ions that are the same on each side. These are called spectator ions because they don't change from one side to the other. And all we'll be left with is the reaction that forms the solid. So we've got one Na plus here and one Na plus here, that's going to cancel. We've got one nitrate and one nitrate, that's going to cancel. So all we're left with is Cl minus plus Ag plus gives AgCl solid. and that would be the net ionic equation for that one. And again, it's just a reaction that forms the solid here. And you could write it either as Cl minus plus Ag plus or Ag plus plus Cl minus. It isn't going to matter. But that is the final net ionic equation for number 21.